Hey, welcome back. Hopefully you took the 7 minutes and checked out those three videos as they really give you a view into what the capture process looked like. So sometimes the calves were simply too old and too agile for us to safely catch, and other times, as you saw in that video, they offered zero resistance. So when we did capture and process these animals, radio marking them, we did it as quickly as possible. So our handling time, we got it down to less than 5 minutes per calf. We wore neoprene rain gear and gloves to minimize the scent. The radio transmitters were placed in bags with sagebrush, again, to minimize the foreign scent. When we processed the animal, there were some things that we needed to get. So we looked at the eruption of the incisors. So this is a good indicator of age. We looked at the condition of the umbilical cord. Was it dry or was it still bloody? The hooves, so newborn calves, their hooves are still quite soft and rough. They harden and smooth out over the first week. The stability of the calf, so if it's really wobbly legged, it's a newborn versus the one you saw in the video that takes off. And then we got some external measurements, so the length of the calf, chest girth, and most importantly, we got the weight of the calf at the time of capture. So we marked these calves with one of two different radio packages. We used expandable breakaway radio collars. So this was a bigger package, but it had a longer life. So the idea was to give us a window into those winter months. So we sewed pleats into these things, and as the elk calf grew, the collar expanded. The cotton thread that held the pleats together broke and the collar expanded. And then we also used an ear tag transmitter. So this was a considerably smaller package. It was cheaper. We could buy more of them and increase our sample size, but the battery life wasn't as good. Both of these collars were mortality sensing. By that I mean they have a little switch in there. When the collar, when the package doesn't move for 4 hours, then instead of going beep, 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 it's going to go beep, 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 beep. So it sends out a mortality signal. We did estimate the difference in calf survival in calves wearing these two different packages, and there was no effect of transmitter package on the probability that a calf survives. Okay, monitoring. So as soon as we radio marked the calves, we then located them. After they were marked, we located them twice daily throughout the entire summer. If we did pick up a mortality signal, beep, 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 so we went in just as quickly as possible to try and determine who done it. I always say it was our natural history mystery. But when we go into a mortality site, you're looking for evidence. So we're looking for tracks. So this is a black bear track on the top left. I can tell it's a black bear because the distance between the toe and the claw is short. Grizzly bears have much longer claws. These are mountain lion tracks, kind of hard to see, but they're rounder and they're not showing any claw marks. So here's a flattened area where a bear bedded down. It's a bear bed site. Top right, so this is fresh bear scat. So here's your little annoying tidbit for the day. Fresh bear scat smells just like black licorice. So I think it has to do with all the skunk cabbage that they're eating. But we could tell, how fresh the scat was. And then occasionally we did have predators on the scene. So this is a black bear that was feeding on the calf elk. And I always used to joke with my technicians, you don't have to run faster than the black bear. You just have to be able to run faster than me or be willing to knock me down. I'm just kidding. We did take a lot of precaution on this study because bears, of course, can be very protective of their kills, as you well know. So we always carried bear spray. So one thing that we quickly realized was that different predators have different ways in which they would kill these calves, and then they had very different consumption patterns in terms of what they would eat after killing a calf. So these are characteristic bear kills. So what the bears would most often do, we presume, is just grab the calf by its skull. It would crush the skull. Not to be morbid here, but this is an eyeball, boop, that's popped out. The bear would crush the skull, consume all of that bone and that fragment. The bear would consume the entire vertebral column, the pelvis, and all of the internal organs. So the rumen, the intestinal tract, everything. So the bears would eat everything and just leave this banana peel of a hide. So we called this banana peeling. So that's about all we would find. The lower leg bones and a bit of hide as they peeled these things inside out. The other thing that the bears would do is later in the summer, as the calves got larger, after they killed calves, what they didn't eat, they would cache. And a bear cache looks a lot different than a mountain lion cache. So a bear is going to drag all of this really heavy duff, make a really big pile with heavy stuff. Sometimes they'll drag whole logs over and put them on top of their cached carcass. Whereas the mountain lions, theirs was a much lighter layer of duff. Speaking of mountain lions, so the lions would kill one of two ways. They would either crush the trachea, the windpipe, or they would bite down at the base of the skull and sever the spinal cord. And then once the calf was killed, the lions would pull out tufts of hair. So you can see the tufts of hair that are pulled out. Here you can see the lacerations. Those are from the claws. And then we're going to make this really nice circular entrance wounds, breaking away the ribs. And then the lions love the liver. So you can see here it's fed on the liver. So this is very rich in iron. This was a choice part. They also would eat the kidneys, the heart, maybe some of the muscle meat. But the mountain lions would always reject the rumen, right? Because this is filled with plant material, and mountain lions are the most carnivorous of the order Carnivora, so they don't want that stomach filled with grass. Bears have no problem eating that. Coyotes, they would do it, but the mountain lions, they always pulled that out and rejected it. And then here you can see this light layer of duff, the very neat pine needles all over the dead elk calf. So characteristic mountain lion kill and consumption patterns. So the other thing that we needed to determine was, were these calves actually killed by the predator? Or was the bear just bumbling along and then finds a dead elk calf? Maybe that died from malnutrition or disease and then scavenged that calf. So we needed to determine whether the bites were made pre or post mortem. And it's relatively easy to do. So we would skin out the animals. And you can see here, this is the canine puncture wounds. This is a cat kill. It's crushed the trachea. Here's another kill on the top right. This is a bear kill, but you can see I've pulled back the skin, and you can see all this blood trapped up underneath the skin. So this is called subcutaneous hemorrhaging. So what this suggests is, when this bite was made, those are the canine puncture wounds, the calf's heart was still pumping. There was blood pressure in the arterial system because the blood squirted out underneath the skin. The other thing is, you can see the dark part around the canine puncture wounds, right? So this is bruising, right? So this is lots of capillaries that have blown up in response to that trauma. So we can tell that this wound was made pre-mortem, not after the calf had died. The other thing that we did on all of the calves is we attempted to assess their nutritional condition. So we would look for the amount of fat that was around the kidneys if the kidneys were still there, which didn't happen all that often because they were often consumed. But one thing we did check on every calf was the condition of the femoral bone marrow. So if you saw that femur in half, right, and you turn it upside down and that marrow just runs out and it's all dark and liquidy, that means the calf had less than 7% body fat. And this was done, that was a paper by Thorne, research that was done at the Starkey, which showed the condition of the marrow in very nutritionally deprived animals. Healthy bone marrow kind of stands up like you see here. It's spongy. Later in this module, you're going to watch an amazing video on the Serengeti, and you're going to be thinking about wildebeest population regulation, and the field biologists are doing the exact same thing. Whenever they have a mortality seen in the field of a wildebeest, they saw open that femur to look at the condition of the femoral bone marrow to understand the underlying condition of the ungulate. So that's how we were able to tease out true predation versus calves that may have been extremely malnourished and therefore were susceptible to predation or died from predation and then were scavenged. So this was an amazing scene. We were incredibly lucky to find this. So this was not one of our collared cows. We had a local rancher that was doing some horseback riding up in the high country, and she came across this dead cow and let us know. We got to the scene just as quickly as we could. And so this was a cow elk that was killed by a sow black bear and her cub while in the process of giving birth. Okay, so you can see the canine puncture wounds here. It's a good-sized bear, either a large black bear or a small grizzly bear, and we looked at a lot of skulls to try and get a distribution of those two species of bears. But you can see all that hemorrhaging, the dark around here, the bruising around those canine puncture wounds. So there were other bites on this bear where they were much smaller. Okay, so it suggested that there were at least 2 bears on the scene with different canine distances that were feeding on this cow elk. So she was extremely dilated. She was in the process of giving birth. Here's the amniotic sac, and this was all that we found from the calf. So this was remarkable. What this showed was these sows were actively hunting these cow elk while they were giving birth. So this black bear or grizzly bear likely caught wind of this cow elk that's in the process of giving birth, and pushed her and pushed her and pushed her, and finally she can't stop the process, and the bear attacks. Other thing that it demonstrated was that sows were teaching their cubs how to hunt. So this was really big. So previously, most folks thought that bears did prey upon calf elk, but it was somewhat lucky. They just were foraging and they stumble across calf elk and they eat them. But what we found was that these bears were actively hunting the calf elk. So we would sit and we would watch, on multiple occasions, we watched bears, and they're working in between the sagebrush and the juniper, right in the area where the cow elk would stash their calves, in the areas that we were looking for calves in order to put radios on them. So it was literally a race against these bears to radio collar these calves before the bears got to them. So not all elk calves died from predation. So this was an elk calf that died of malnutrition. It was abandoned by its cow just a few days after we marked it. We don't know if collaring this animal is what made the cow abandon the calf. We do know that abandonment was rampant that year. I'll show you some slides here in just a second, but we found a dead elk calf that we had never handled, that hadn't been marked, that had also been abandoned. So we'll come back to that. But abandonment and malnutrition was definitely an issue in 2002. This is a calf that we found in a creek. So the proximate cause of death was drowning, but the ultimate cause of death was an upper respiratory infection. So all calves that were whole like this, we packed out and we necropsied at the state lab, and they ran tissue samples to determine if there was underlying disease. So hopefully you recall, we're collecting all of this data so we can test these three different hypotheses to try and determine what was suppressing calf elk recruitment. But the way that science works is you create these hypotheses, these possible explanations based on the context, your observations, and then you make a series of predictions about what you would expect to see in the things you measured if this particular hypothesis was supported or if it was refuted. But the ultimate goal is to try and eliminate each of these hypotheses. So this is exactly what we did. We created a prediction table, very similar to the table that I went over with you in your last lecture. So let me show you how this works. We've got our three hypotheses. The big bad wolf done it. It's too many elk, it's high densities of elk, or it's a lack of mature bulls. And here are just 6 things that we measured. And so let's think through what we would expect to see if each of these hypotheses were in fact operating. So on this prediction table, I want you to fill it in, okay, using these 3 possibilities: high, low, or no effect. So what do I mean by that? Pregnancy rates, okay? If there are too many elk, there are high densities of elk in the system, then there's going to be nutritional limitations. And so we would expect elk pregnancy rates to be low, at least yearling elk pregnancy rates. Same with our lack of mature bulls hypothesis. If there aren't enough mature bulls to breed those cows during the rut, then we would expect pregnancy rates to be low. Are predators going to affect pregnancy rates? Probably not. Okay? So let's think about another one. Calving synchrony. Are predators going to impact how synchronous that calving period is? Probably not. Really, what we would expect to see is the mature bull hypothesis. So if there are not enough mature bulls in the system, then we would expect calving synchrony to be quite low. We would expect it to be asynchronous. Okay, so put me on pause and go through and think through each of these different measurements and what you would predict to see if each of these hypotheses was either supported or refuted. So, for example, calf birth weight. We would expect that to be low if there are too many elk in the system. Hopefully you see how that works. Okay, on to some data. Drum roll, please. So we'll start with the cows. So we used a helicopter and net guns to radio mark 28 cow elk. Mean age was 5 years old. What's most important here, 27 of the 28 cow elk, 96% were pregnant. So pregnancy rates were high. Pregnancy rates, at least in prime-aged adults, did not seem to be an issue. 50% of the elk that were collared had been exposed to anaplasmosis as detected by antibodies in their blood, and 32% to leptospirosis. So in comparison to other published work, this was relatively high. So it suggested that disease exposure was high. We marked 121 newborn calves over 3 years. We caught 90 of these calf elk using a helicopter. This is a shot from a helicopter from above. You can see that wobbly-legged calf and her mom, the cow, and 31 of these captures on the ground. On average, we predict that we caught about 10% of each cohort, and we stratified it by the different herds across our study site. Our captures occurred between May 25th and June 8th. 98% of our calf births occurred within a 20-day period. So our calving window was very synchronous. Over 3 years, we documented 28 confirmed mortalities from our radio-marked sample of calf elk. Of those 28 mortalities, 70% were attributable to predation. But you can see here from the suite of predators that killed calf elk, if there was a predator that was influencing these herds of elk through top-down regulation, then it certainly wasn't the wolf. So we just had one potential wolf kill. It was actually an unknown canid. It could have been a gray wolf, or it may have been a Great Pyrenees sheepdog. But the primary predator on our calves were actually bears, followed by mountain lions, and then coyotes. And then we had several that we just couldn't confirm. There just wasn't enough left. And then we had one that was harvested by humans, perfectly legal, during archery season. We also had relatively high rates of both malnutrition and disease. So we had 22% of our calves that died from malnutrition, one that was malnourished and then killed by a coyote, several that were abandoned, and then we had a couple of instances of disease. I showed you that one that we recovered from the creek that had the upper respiratory infection. Unsurprisingly, the vast majority of the calf elk mortality occurred during that early neonatal period, during the first 6 weeks of the calves' lives, because this is when they're smallest, they're slowest, and they're most susceptible, they're most vulnerable. You notice this is when the black bears really pick them off. We don't see cougar mortality, mountain lion mortality, until about the 5th week. That's because initially these calves are born in the sagebrush flats, and then as the summer wears on and the weather warms up, they move up into the ponderosa pines, up into the high country, and that's when the mountain lions begin picking them off. As late as 15 weeks. All right, we also estimated calf birth weights. Remember I showed you when we were processing the calves that we collected data on their incisor eruptions, on the condition of their umbilical cord, on their hooves. So what we were trying to do is determine how old the calf was on the day that it was captured. Was it 1 day old? Was it 5 days old? Was it 7 days old? So we estimated the age of the calf at time of capture, and then of course we got capture weights. And we regressed capture weight on capture age, and we created these linear regression models. So as calves get older, then they grow. And so essentially what that y-intercept represents is the estimated calf birth weight. So that's how we estimated calf birth weight on, say, a 5-day-old calf that was caught. And then it also gave us initial growth rates over that first week of their life. So that's the slope of this linear model. All right, so this is the first big year-to-year difference that we found in this study, and that was birth weights. So females were significantly lighter in 2002 than they were in 2003. And males were significantly lighter in 2002 than they were in both 2003 and 2004. You can see here, this is in kilograms, all right? So the difference here is over 2 kilograms, so that's over 4 pounds, which is a lot of mass when you're talking about a 35 pound animal. So birth weights were significantly lower for both females and male calves in 2002. All right, so you remember our prediction table. So what have we learned? Okay, pregnancy rates were high. So we can eliminate both of those, right? So we can put a big X there. They were not low, they were high. Calving synchrony, it was quite synchronized, so we can X that out. Predation rate was kind of middle of the road. It was 70%, but relative to other studies, particularly those in Yellowstone National Park and those in northern Idaho, our predation rate was relatively low. It was really just 1 year that we had high predation rates. So I've X'd those out as well. Malnutrition at 30%, malnutrition and disease, that was pretty high. So you can see kind of how I've gone through and interpreted these data relative to other studies. But for now, based on your interpretation of these data, which of these three hypotheses should we eliminate at this point? And hopefully it's quite clear. None of those predictions held. So we can eliminate that lack of studs hypothesis. So mature bulls were not an issue with respect to declining recruitment based on what we measured. So what absolutely blew us away was the unbelievable year-to-year variation in calf survival rate. So in 2002, 71% of our marked sample died, compared to just 11 and 14% in 2003 and 2004. So it was incredibly variable from 1 year to the next. So this was a calf that we never marked, that we never handled, and we found it when we were searching to mark other calves. We just come across this dead calf that's in the middle of the sagebrush on the calving grounds. And we necropsied it in the field, and it had absolutely nothing in its gastrointestinal tract. So it starved to death. It was abandoned by its cow, and it was never handled by us. So we detected this calf, as you probably guessed, in the year 2002. In the year 2002, black bear predation was significantly higher than it was in 2003. And in 2002, malnutrition and disease were both significantly higher than they were in subsequent years. So again, we did see high predation rates and we did see high malnutrition and disease rates, but it was just in 2002. 2003 and 2004, malnutrition and predation wasn't really an issue. So why? Why was calf mortality so much higher in 2002 in comparison to 2003 and 2004? You'll recall at the very beginning of this case study, I mentioned to you that sometimes in wildlife research, you just get lucky. And we got lucky. In terms of when we radio marked these calves. So after 2002 was such an anomalous year, we went back and we looked at the weather data from a weather station in Ovando on our study site. And what we learned was that spring in 2002, it was extremely cold. So on average, the mean daily temperature between March and May in the spring of 2002, it was the second coldest mean in over 100 years. Further, March was just brutal at negative 6.44 degrees Celsius relative to other years when it was on average above freezing. So March was the third coldest mean daily temperature since 1899. And it wasn't just cold. It was also incredibly dry. So the precipitation total between March and May in 2002 was the second lowest total precip, and this includes snow and rain, since 1899. April, which is when they typically get some good rain, 3 inches here in 2003, There was just a trace of precip. It was the second lowest precipitation total in an April since 1899. So it was extremely cold and it was extremely dry. So what this does is it impacts the phenology of the plant community. By that I mean the timing of the plant's life cycle. So in the spring in the mountains, we expect to see a green up as the weather rapidly warms and the snow melts and you get good precip and you get this greening of the mountains. The elk have evolved to calve during this green up so that they can get lots of nutritious, high protein forage to support their calves. So the problem in 2002 is this green up never really occurred. So these cows, they're incredibly stressed physiologically. They have to produce milk in order to nurse these rapidly growing calves, and they simply weren't able to produce enough milk in 2002. So we saw high rates of abandonment, we saw high rates of malnutrition, and this also relates to bear predation. But first, for number 6, how did spring weather conditions and then the resultant plant phenology of the spring green up differ in 2002 on our study site in comparison to years 2003 and 2004? Hopefully you can answer that. And then for number 7, I'd ask that you watch a portion of my TEDx talk. So I was invited to deliver a TED talk at Utah State University a few years ago. If you just want to complete the case study, I just ask that you watch between minute 4 minutes and 31 seconds and 7 minutes. And then after watching that, I want you to describe the relationship between spring weather conditions in 2002, calf nutritional condition, and black bear predation rates. So be sure and explain why black bears were likely more reliant on calf elk in the Blackfoot Valley in spring 2002. If you'd like to earn a bit of extra credit, I've built in an extra credit question on this case study. So if you'd like to earn up to 10 points extra credit, up to 30 out of 20 on this case study, then I'd invite you to watch the entire video. It's not terribly long, it's about 12 minutes, and then compose a 300 to 500 word maximum summary highlighting the main ideas in this TEDx talk. It's more than just elk and bears. And then reflect on how this may or may not connect with you personally based on your own life experiences. So a 300 to 500 word synopsis of my TED talk will earn you 10 points extra credit. So as predation alone across the entire 3 years could not account for the declines in calf recruitment that we were seeing on spring green up flights, I took a closer look at those flight data back to 1980 in west central Montana. And so what I did is I calculated lambda for each of those years and then plotted lambda as a function of the total number of elk observed. And what you see is as the total number of elk increases on the landscape and the density increases, lambda values decrease. So only 28% of the variability in lambda was explained by the total number of elk observed, but that's still a substantial amount of the variation. So what this is showing is part of the variation from year to year in population growth rates is certainly attributable to density-dependent effects. So what's happening? So since 1980, there was large-scale conversion of winter habitat into irrigated agriculture for beef cows. And on these large private ranches, we have decreasing public access to harvest these elk. As a result, the elk herd grew from 6,000 elk to over 16,000 elk in 20 years. Okay, so there was clear density dependence going on between the size of the elk herd and the population growth rate. If our management objective is to increase calf-cow ratios, if that's the goal, what was truly needed was not predator control, but increased access on these large private ranches to harvest cow elk via conservation easements. By bringing total elk numbers down, by bringing that density down, you're going to get more calf production.